Hi there! Welcome back to Super Awesome Calculus. Today we're still on Chapter 1, Functions, and now we're going to go over different types of functions. Now you remember last week we talked about last lecture we talked about 4 different ways that you could represent a function. Today we're going to talk about various different types of functions, but first we're going to go over the big problem from last week. So, last week's question was as follows. A spherical balloon with radius r inches has volume Vr equals 4/3 pi r cubed. Find a function that represents the amount of air required to inflate the balloon from radius r inches to a radius of r plus 1 inches. So to solve this question, we have to look at what we know. What do we know? Well, we know that the balloon has a volume. The balloon volume is 4/3 pi r cubed. Okay? That's something that we know. We also know that we want to know. We need to know what we want to know. We want to find a function that represents the amount of air required to inflate from r to r plus 1. Now we don't see on that equation r plus 1 here, do we? No, but it's pretty easy to find. V is a function of r. So if we want V is a function of r plus 1, which is exactly what it's asking for, a radius of r, a balloon with a radius r plus 1 inches, it would stand to reason that that equation would be 4/3 pi, replace r with r plus 1 cubed. So that's pretty simple, right? Where there was an r in the first one, we're looking for r plus 1. Okay, replace r with r plus 1. But we're not done here. You see, it's not asking us what is the radius of a balloon with volume r plus 1. It's asking us to find a function for the amount of air required to inflate from r to r plus 1. So we know r plus 1 is going to be bigger than r. We're blowing up a balloon. It's at r. Then with an extra breath, it's at r plus 1. So to find the difference, I mean, you can hear it right there, the word difference. We're trying to find the difference between this and this. And in mathematics, when we're looking for a difference, we're usually going to be talking about subtraction. So, what we want is V r plus 1 minus VR. And it turns out that the answer is 4/3 pi r plus 1 cubed, VR plus 1, VR minus, we replace VR with its function, 4/3 pi r cubed. Now if you really want to, you can simplify this. You can expand r plus 1. You can do the multiplication, but really, at least as far as math professors that I've had, if you get to here, you're done. That's it. So that's what I would consider a good answer for that question. That is a function that represents the amount of air that's required to inflate the balloon from that to that. So now that we've covered the big problem, let's move on with today. Today we're going to be talking about, use blue, see if this looks good, math modeling. My handwriting is awful. This is why I'm not a teacher. And functions. All right. Now, if you've taken pre-calculus, oh, you can't even read that. I can't even read that. If you've taken pre-calculus, this will probably be a huge review for you, but regardless, you still might get something from it. So, we learned a little bit about mathematical modeling from what we just did in the big problem from section 1.1. Section 1.2, we're going to talk a little bit about models. Now the process is very simple. You've got a real world problem. Like I said, it's very rare that someone's ever going to walk up to you and be like, hey, you know, Bill, I was really wondering, what's the derivative of 7x squared? You know, no, they're not going to ask you that. If they do, it's 14x, but they're not going to ask you that. But they might ask you something like the balloon problem. They might ask you something having to do with various things that they're trying to buy, you know, any kind of different thing. So what you're going to do is you're going to take that real world problem, you're going to formulate. We did this yesterday, actually, with the 4 different ways to represent a function. I said the real world problem. This is how many sandwiches I'm making. How many am I going to make the 5th day? That is a real world problem, and we formulated an answer to it. Then we drew a mathematical conclusion. We found that if our f of x equals x squared, then on the 5th day, f of 5, I would make 25 sandwiches. We drew a mathematical conclusion. And then we can tie that into real-world predictions, which is also kind of what this was. The conclusion was that the data that we had was f of x equals x squared, basically, you know, restricting to positive, of course. F of 5, 5th day, would be 25. We were able to accurately predict it. People use mathematical modeling all the time. It doesn't matter if you're working at a grocery store, managing a Fortune 500 company, or playing video games. I mean, you can actually do some interesting things playing video games. You can watch baseball and come up with functions. People do this all the time. You can use mathematical modeling in just about any field. And that's basically it as far as mathematical modeling goes. Now what we're going to spend the bulk of today's lecture talking about are different types of functions. I'm going to move fairly quickly in the interest of brevity. For a much more detailed exploration of these functions, you might want to explore the book, the James Stewart textbook. You might want to look for some of these things online, because for instance, we take something like a polynomial. I'm going to assume that you basically know what a polynomial is, and I won't break down all of the nitty-gritty a to the n, x to the n. I'm not going to go over that. So basically, this is going to be a very quick overview of all the different functions that we're going to be seeing in this course, or especially the first part of this course. So, the first thing that we're going to talk about are polynomials. Now, polynomials, I'll draw some examples. Polynomial, like I said, we're not going to go over the formal definition of this. It's pretty basic. It's a sub n x to the n plus a sub n minus 1 to x to the n minus 1. But basically, here are some examples of polynomials. 2x squared minus x plus 8. That's a polynomial. Another polynomial is 3/4 x plus square root 2. That's a polynomial. Another polynomial is x cubed minus 8 for simplicity. Okay, these are polynomials. Now each of these 3 polynomials I've picked here, I have a specific name for them. This right here, you'll notice the first number, the first term of the polynomial, if it's in order, you'll see the degree. Now the degree is the highest order polynomial we're talking about. If we've got x and we've got x squared, then x squared is the highest degree polynomial. If we've got x to the 8th and x to the 5th, x to the 8th is the highest order polynomial. So here we have x squared. So the degree, we say, of this polynomial is degree 2. And if it's a degree 2, we call this quadratic. You probably know about the quadratic formula. If you don't, we'll go over that probably at some point. But this is a quadratic polynomial. If it is degree 1, like this right here, it's 3/4 x. It doesn't need to be x to the 1. We understand it's x, degree 1, plus square root of 2. Square root of 2 is a number. It's like 1.41 something. And we know that if it is degree 1, it's linear. So this is a linear function. It's going to look kind of like a line. In fact, it is going to be a line. Slope 3/4, intercept square root 2. And then we can look here, x cubed minus 8. You might guess what's the degree here? That's right, it's degree 3. So we call x cubed minus 8, you might guess that we call this a cubic function. And in general, you can say that any power function is f of x equals x to the n. So you can have x to the 974th, that's a 974th degree order polynomial. That's pretty nasty. Let's see, so those are polynomial functions. And that would be f of x equals any of those things. F of x equals 3/4 x plus 8. I just want to point out very quickly, for instance, last time I mentioned briefly about a function, and I wrote an equation on the board. Every once in a while, since I'm not in a classroom atmosphere, I mean, I've never taught, but oftentimes even the best math teachers make mistakes, and I'm certainly not the best, so I'm probably going to make quite a few. If I make any mistakes, I'll try my very best to correct it either as soon as possible in that lecture or later in the lecture. And if I can, I'll try to find a way to address that problem in the subsequent lecture. And if you catch anything, let me know. All right, now that I've got that out of the way, we're going to talk a little bit about root functions. Root. Now, as you might guess, this has something to do with square roots, or any kind of root for that matter. The nth root of x. Now, what does that n mean? That means that this could be f of x, could be square root of x, it could be the third root of x, the 7th root of x, it can be any of those. These are all root functions, and they all look the same. They all look kind of like this on a graph. It's a root function. We're also going to look at a fair amount of reciprocal functions. You've probably seen this before. A reciprocal function is something, I mean, the most basic example here is 1 over x, because it's the reciprocal of x. X, 1 over x, is the reciprocal. And if you remember, this looks kind of cool. It's asymptotic, a hyperbola. That's pretty bad, but that's basically what it looks like. And it never, if you remember, it never actually touches the axes. And that's a reciprocal function. 1 over x equals f of x. Two other classes of function that we'll be looking at, and we'll be looking at a great deal. We're going to look at a lot of rational functions. Now, a rational function, f of x equals p of x over q of x. A good example of this would be you take two polynomials as a ratio. That's why it's called rational. You have a ratio of two different polynomials. 2x to the 4th minus 7x plus 2 over x squared minus 3 halves x plus 1. That's a rational function. It's an interesting rational function. And that's just what that looks like. Anytime you have a ratio of two things, you have a rational function. Finally, well, not quite finally, but we're going to look at algebraic functions in this course. Algebraic functions are basically any combination thereof. The book gives a couple good algebraic functions, so here's one of them. The square root of x squared plus 1. All right, it's a mix of a polynomial. We've got the polynomial part right here, but it's a root function as well. There's also, this one's nice, x to the 4th minus 16x squared over x plus square root of x plus x minus 2 times the square or the cubed root of x plus 1. That is a really, really nasty looking function. Right? The point is that these are both algebraic functions. We're going to look at a lot of things like this. I can promise it. We'll look at quite a few things like this. We're not going to look at very much like this. That's a little bit ugly for this course. But I can't promise that your professor or that your AP exam or whatever will be quite so forgiving. Finally, the last two functions we'll look at are, we're going to look at logarithmic functions. Logarithmic. We're going to look at a lot of these. Basically, this is f of x equals the log x, or log to the n. Basically, we're never going to use that. We're going to almost exclusively, when we talk about logarithms, we're going to use the natural log, ln. And when we talk about exponential functions, which we're going to talk about next time, or the time after that, we're going to be focusing almost exclusively not on a to the x. We're going to focus almost exclusively on e to the x, which is the inverse of the natural log. And these two types of functions can be called transcendental functions. In other words, they're functions that can't be described algebraically. I forgot a very important type, and it's a type of function that we are going to look at quite a lot, and those are trigonometric functions. That's functions like f of x equals sine x, f of x equals cosine squared x plus tan x, and eventually we're going to start looking at things like f of x equals arctan x. These are trigonometric functions. These are also transcendental functions. In other words, they're not algebraic. If they're trigonometric, like this, inverse trig, featuring logarithms or exponentials, they're not algebraic elementary functions, or they're not algebraic functions. They're transcendental functions. And also, I don't know how far I'll get with this. I'm hoping to cover the first semester calculus, which would roughly correspond to calculus AB for high school students. But if I get to second semester calculus, or BC, we're going to be talking about infinite series, and there are transcendental functions that are quite interesting that arise from infinite series, a sum of an infinite amount of numbers. Anyway, those are the different types of functions. So today we're going to go with another big problem. We're going to look at another function. Here we go. The relationship between Fahrenheit, F, and Celsius, C, temperature scales is given by the linear function f equals 9/5 c plus 32. Sketch a graph of this function and tell me what is the slope of the graph and what does it represent? What is the f-intercept and what does it represent? you should have fairly little trouble tackling this assignment. And good luck, and thank you very much for coming along. And next time, we're going to look at how to transform some of these functions that we've just talked about today. All right, till then, take care, y'all.